the questions that we did in our virtual class today. The first question was determine the length of line B to 1 decimal place. So they're asking for how long it is, not for what the slope is. Now, if this was line C or D, it would be very easy because you could simply count the blocks. But for B, because it's a diagonal line, it's really much harder to see how long this line is. So what we can do is we can draw a right triangle, and we can read this side length and see that it is 2 units. And we can read this side length, which is 5 units. Then we can use Pythagorean to calculate the length of line B. So we would do a squared plus b squared, and we'll call this c, is equal to c squared. So 4 plus 25 is equal to c squared. So 29 is c squared. And we would have to root both sides. Now, normally when you root both sides, you are going to get a positive and a negative answer, so 2 different answers. But in this case, we only care about the positive answer because you cannot have a negative length. And it asks us for 1 decimal place, so in my calculator, I'm getting that c is equal to 5.38 dot dot dot. And so you would be expected to round that correctly to 5.4 units. Determine the slopes of A, B, C, and D. So if we're looking at the slope of line A, most of you would know that we're looking at the rise over the run. So if we calculate the rise, we're going to see that this is 7 units from top to bottom, and the run is 5 units. So most people might say that the slope of A is 7 over 5. But you have to remember to check to see if maybe this slope is negative. So we always read slopes from left to right. And because it's falling to the right, we would say that this is a negative slope. B, on the other hand, is rising from left to right, so it would be a positive slope. And let's just check the rise, which is 2, and the run, which is 5. So that's positive 2 over 5. The slope of C, we're looking at a rise of 5 and a run of, well, I would say 0 from those 2 points. But you cannot divide by 0. So what we're seeing with this particular line is that the slope is undefined. And that's true of all vertical lines. The slope is undefined. And for line D, let's look at the rise. Oh, the rise between these points is 0. There's no rise. And the run is 1, 2, 3, 4, 5, 6. So the slope of 0, or slope of D is 0. And all horizontal lines have a slope of 0. If you are asked to determine the slope between 2 points that are not on a grid, you can use the slope formula. The key to this formula is not plugging things in incorrectly and not missing negatives. So just to be safe, I always label my points. This is x1, this is y1, this is x2, and this is y2. So when I plug them in, I make sure to plug them in the correct spots. So -4 minus y1, which is -3, and then x2, which is 5, minus x1, which is -2. Watch those double negatives because the top becomes -4 plus 3, and the bottom becomes 5 plus 2. So we're looking at -1 over 7. And that doesn't reduce any further, so this is the slope between those points. There are questions that ask you to find a missing value, which is a little bit trickier. But we can still use the slope formula. So here's x1, y1, and x2, y2. We don't know what y2 is. It's k, so we're going to find k. But we do know what the slope is, which is 3. So we're going to set this up as best we can. So y2 minus y1 is k minus 6, and x2 minus x1 is 5 minus 4, and that's all going to be equal to 3. So I'll simplify this as much as I can. 5 minus 4 is 1, and lucky for us, that means that I can ignore the 1, because a 1 in the denominator doesn't mean anything. So what we're getting then is that k is equal to 9. So with these ones where you have to find k, just set up the equation with k in it and then solve for k. You should have enough clues to do that. Here's a harder example when they're asking us to find k. So here's x1, y1, x2, y2, and they've given us a slope of 2 over 7. So y2 minus y1 over x2 minus x1 is 2 over 7. So we'll simplify that as best we can, which is negative 2 over k minus 2 is equal to 2 over 7. So you can either flip both of these fractions, if that makes sense to you, or the other way I want to deal with this, because I don't like k being in the bottom, is I need to kill off all my denominators before I can find k. The best way to kill off a denominator is to multiply both sides by that denominator. So I'm going to multiply both sides by k minus 2. This is review from Math 15. You should have learned how to do this. And in the top, just to make my life a little easier, I'm just going to distribute that too. 2k minus 4 over 7. So yay, k is now in the top. Unfortunately, we still have a denominator, which I do not like. So I'm going to kill off this denominator by multiplying both sides by 7. And we end up with negative 14 is equal to 2k minus 4. So I will add 4 to this side, add 4 to that side, and we're ending up with negative 10 is equal to 2k. So we'll divide both sides by 2, and k is equal to negative 5. So the concept is easy. The algebra can get very, very ugly, especially when k is in the bottom. The moment of brilliance is realizing that if k is in the bottom, I need to multiply both sides by the denominator to get k up into the top. So again, this example, we're being asked to find k. Here's x1, y1. I always label them. Otherwise, I end up plugging the wrong numbers in, and we don't want to lose a mark because of that. So y2 minus y1 over x2 minus x1 is equal to negative 2/3. So k minus 3 over 6 is equal to negative 2/3. Luckily, this time, we have k in the top, so we don't have to worry about that. Unluckily, we still have a denominator, which we do not like. So I'm going to multiply both sides by 6 to try and get rid of this denominator. So we have k minus 3 is equal to negative 12 over 3. Luckily, that simplifies to negative 4. And then we can add 3 to both sides. We will get k is equal to negative 1. In the last example, they've made it a little bit harder. They're asking us to find point B, but they haven't given us even one coordinate of point B. Instead, they've given us a clue saying that B is on the x-axis. So to wrap our heads around this, I'm just going to draw a sketch, which is a good tip whenever you can't wrap your head around what's happening here. So 2, 3. Here's point A over here at 2, 3. And point B makes a slope of negative 1/2. So negative 1/2 is a slope that is, I don't know, sort of like this. So it's going to be probably falling to the right over here somewhere. No, it's a positive 1/2. Never mind. It'll be rising to the right. So if I were to guesstimate what the slope would look like, it would look something like this. Positive 1/2 slope. Pretty shallow, but positive. So point B is on the x-axis. So point B is somewhere over here. What are the coordinates of that point? Well, we don't know exactly what the coordinate of the x-coordinate would be. We're going to call that k. But we do know that if it's on the x-axis, the y-coordinate must have been 0. And therein is your moment of brilliance, realizing we actually do have some information. K, comma 0 is point B. You cannot count necessarily, like maybe k comes out to be a whole number, but maybe it doesn't. And if it doesn't, we still have to do the algebra. So once more, I'm going to label x1, y1, x2, y2. And I will plug that into my formula, y2 minus y1 over x2 minus x1. And we do know the slope is 1/2. So what do we get in the top? Negative 3 over k minus 2 is equal to 1/2. So then we, again, realize k is in the bottom. We don't like that. So we're going to multiply both sides by the denominator in order to get k into the top. So we get negative 3 is equal to k minus 2 over 2. And we're just going to kill off this last denominator here by multiplying both sides by 2. And things will look a bit better after that. So negative 6 is equal to, and I will distribute that, 2k minus 4. We'll add 4 to both sides. Negative 2 is equal to 2k. We'll divide both sides by 2 and end up with k is equal to negative 1 again.